Okay, let's just do a quick review. How would I calculate x plus y cubed? Hopefully you're okay with breaking this down into x plus y squared times x plus y, right? And then this you know, right? So it's x squared plus 2xy plus y squared, okay? And of course that's going to be, if I want to multiply that out, it's going to be that times an additional x plus y. Okay, so let's kind of see how that works out. Okay, so what I'll do is like this kind of method here. I could use a box also. That would be helpful. Actually, let me use the box. X, y. Okay, and boom, boom. Okay, so I'm going to put those things on that side of the box. Then I have x squared, 2xy, y squared. Okay, carefully multiplying everything in the box together. X cubed, I'm going to get 2x squared y, multiplying those together. Then I'm going to get xy squared. Here I'm going to get x squared y. Here I'm going to do 2xy squared. And the last box is y cubed. Okay. So if I sum up all these things, the nice thing when you do it with this box method is these like terms tend to be on the diagonals depending on how you set it up. Okay, so you end up with x cubed, and then those are kind of like terms, right? So you get 3x squared y, and then you're going to get 3x y squared, and then plus y cubed. Okay. So we'll kind of keep that in mind when we need it for a later calculation. Okay, so let's go back to this idea, okay? And I'm going to try to motivate how Pascal's triangle can be used in the real world. Okay, so let's say we want to expand x plus y to the 0. Well, of course, that's just 1. Okay, how about x plus y to the 1? Okay, so I'm gonna write it a little funny at first, but it's gonna be 1x plus 1y. Okay, let's do x plus y squared. Hopefully you can do that out mentally. 1x squared plus 2xy plus 1y squared. Okay, hopefully you're recognizing something. Okay, we already did x plus y cubed on another page, and what it looked like was 1x cubed plus 3x squared y plus 3xy squared, and then plus y cubed. Okay, so hopefully what you're able to recognize is you might see some coefficients. If we just write down the coefficients that we've used so far, what are those coefficients that we've used so far? We've used like 1, and then 1, 1, right? And then 1, 2, 1 here, and then we use 1, 3, 3. Oops, forgot the 1 there. 1, 3, 3, 1. Okay, so hopefully you're recognizing that when you expand these kind of binomials, when you do the expansion, the coefficients that show up are the same numbers that are in Pascal's triangle. Okay. So just judging upon that so far, if you had to expand x plus y to the 4th, let's think about what that would look like, okay? So probably it's going to use the coefficients 1, 4, 6, 4, 1 from Pascal's triangle, and let's just kind of see how they come into play. Okay, so hopefully you realize you're going to start with a 1, okay? You're going to start with the highest power of that thing, okay? And I'm going to write some extra terms in here just so you see what happens. It's not necessary to write this, but hopefully you'll just kind of see the pattern from this. I'm going to write y to the 0, okay? So x to the 4th, y to the 0. Then I'm going to take the next coefficient from Pascal's triangle. I'm going to take a 4, and it's going to have x cubed, and then it's going to have y to the 1 power, okay? And then the next thing I'm going to have is 6 from the triangle. I'm going to have x squared, y squared, okay? The next thing I'm going to have is a 4. Now I'm going to have x and then y cubed, as I'm running off the page here, okay? And then the last thing I'm going to have is 1. Now this is going to be kind of silly. I don't have to write the x to the 0, but I'm going to go ahead and write it, and then it's going to be y to the 4th. Okay, so the thing I want you to realize with this expansion, I realize you can't see the original number. First of all, the coefficients here are 1, 4, 6, 4, 1. Okay, now what's happening with the variables is it's like the 1 counts down as the other counts up. So the powers on the x go 4, 3, 2, 1, 0. Could have put a 1 there, I guess. Okay. At the same time, the powers on the y are going 0, 1, 2, 3, 4. Okay. So again, one starts at the highest value, counts down. The other starts at the lowest value of 0 and counts up. And hopefully what you could do if you wanted to is verify it if you wanted to make a box and then take this thing and then multiply